Let's take a look at the normal random variable. Some notation that you'll see referring to the distribution. It'll either say normal or say in for normal, of course. And then it'll have a number, comma, another number. Now, first number is mu, that's your mean. And next number is sigma squared, which is your variance. Both these are population, of course. Now, here's a formula that we're going to be using. And this is a way to standardize a normal random variable. And we'll be looking at more about this, but z is equal to x minus mu over sigma. And a random variable z is said to have the standard normal distribution with mu is equal to 0, sigma is equal to 1. So if it says standard normal, it's by default 0 and 1 for the mean and standard deviation. Here's how we're going to be plugging into the R programming language. If it asks you to find a probability, percentage, proportion, or area, all those mean the same in terms of which function to use. Also, if it asks you something about unusual, is this unusual? Then they're asking you about whether it's less than 5% for the probability. Okay, so if it asks for any of those, you use P norm. And then x, comma, mu, comma, sigma. Now, the x will be the given to you. And what this is going to do is it's going to find the probability to the left of x. And of course, mu and sigmas are population mean and population standard deviation. If it doesn't have any of those words, but asks you to find a value, including percentile. An example, this would be find a score, find the age, find the number of pages. Well, that's not a good example, but if it asks you to find anything else except for these words, then more than likely it's this one here. And we'll use Q norm, and you'll pass in a probability. And probability is always the area to the left, and then our mu, and then sigma. And again, for standard normal distributions, leave mu and sigma off, and it will default to 0 and 1. Or you could put 0 and 1 there. Work the same. Okay, generally, when we're using R, to find probabilities, you identify the mean, that's mu. You identify the standard deviation, sigma. And those are usually given. And then use a table on the following slide to determine how to enter the function. So, if it's less than or equal to A or less than A, both those are the same for this, use P norm, A, comma, mu, comma, sigma. If the probability is x is greater than or equal to A, you do 1 minus P norm, A, comma, mu, comma, sigma. And if it's probability between A and B, and these can be less than's or less than or equal to, these can be greater than equal to. It does not matter if the lines are underneath, it's still the same formula. P norm, B, mu, sigma, minus P norm, A, mu, sigma. Okay, this is generally what a table looks like. Now, some books are a little bit different, so I want to just approach that idea. And this one, this shows you a picture, and this table is based upon the area to the left. I've seen some very bizarre ones where the area is to the right. So if you do it by hand, if the area is to the left, it's actually easier, in my opinion. Okay. Now we're going to do this two ways. We'll do it by hand using tables, and then we'll do it using our programming language. So you'll see lots of different examples of this. It says determine the area under the standard normal curve lies to the left of negative 2.92. Okay, so let me do a screen capture here. And then come over here and do an edit, paste. There we go. And let's see. Edit, deselect, choose my paintbrush here. Okay. So this problem's asking us to find, determine the area under the standard normal curve lies to the left of negative 2.92. So negative 2.92. 2.92. Now, that's not actually the way the picture looks. We're just trying to see the left and right and so forth. Says standard normal, so we know that means that our mean is 0 and standard deviation is 1. Okay. Negative 2.92 would be further to the left, but it doesn't matter. It's to the left of this. We said standard normal, so we know our mean is 0. We know our standard deviation is equal to 1. Now, if your mean is 0 and standard deviation is 1, then you can use the standard normal distribution directly. Now, we want to split this up into two separate parts. We want to take the whole part here and the first decimal place. So we're looking at negative 2.9. And then we want to take the hundreds place here and look at it separately. So we're looking at 0.02. When I say the hundreds place, the 2 just carries down and we put a 0 in this place. Now we want to look at the intersection of negative 2.9, which is right here, and 0.02. And where they intersect, this is our answer. So it'd be 0.0018. Now that's because our table is based upon the area to the left. And we'll see some other examples of that. Now, when they say find the area, remember that's same as they're asking to find the probability or percentage. So all those we do it the same way. Okay, so let's redo this. We got negative 2.92. We said the to the left. Well, that's and what I'm going off of here is back to our table here. So we're trying to rewrite it in one of these three forms. So that's our goal. Since it's shaded to the left, that would be a less than or equal to. Now, A is whatever follows the less than or equal to. So this is A. And this tells us to put it into P norm A mu sigma. So P norm A, which is negative 2.92, mu, which is 0, and sigma, which is 1. And you can put it there. It doesn't hurt anything. Or you can leave it off. It defaults to 0 and 1 if you leave it off. Okay, P norm. Oops, let me get up here in my script, even though it worked down there. P norm and negative 2.92. Negative 2.92, and I'll put 0 and 1 just to indicate it. And this is going to be problem number 1. .00175, or rounded to 4 decimal places, 0.0018. So it gives the same value as that. Okay, so let's look at our next problem. Number 2 says determine the area in a standard curve that lies to the right of 0.53. Okay, let me get a picture of the table here. And deselect. And to the right of 0.53. I'm trying to find that right there. Now, when using the table is based upon the area to the left. Well, this is the area to the right. So what we do is if you have it shaded to the right like this, you always rewrite it as 1 minus the area to the left. all of the area probability percentage adds up to 100% or 1. So when you subtract off the right side, that leaves you if you subtract off the left side, that leaves you the right side. So we're going to have 1 minus, and this number we split up, we're going to take the 0.5, and we'll take the hundredths place, 0.03. So 0.5 is right here. 0.03 is right here, and you look at the intersection of those. And that would give us 0.7019. So I got 1 minus 0.7019, 0.2981. Now, again, I'm not drawing these in the correct place, and if you want to, that's fine. When you talk about standard normal, the value exactly in the middle is 0. So 0.5 would be further to the right. I don't care. I'm just trying to visualize the shading, so it doesn't really affect working the problem. Okay, so this was, if I were to write it down, finding it again, this is probability that x is greater than or equal to 0.53. It's not actually x, it's z, since we're talking about standard normal, but we'll go with that. That's this second form here. X is greater than or equal to a. That says 1 minus p norm a mu sigma, and so a, what follows, are greater than or equal to. Let's see. This is a, and that tells us 1 minus p norm a, which is 0.53. And if you want to put 0 and 1 there, you can. There again, those default, so you can just do p norm 0.53 and then close the parentheses. Okay, so down here, number 2, 1 minus p norm. Is it 0.53? 0.53. Okay, so I'll run that. 0.2981, rounded 4 decimal places. So 0.2981. Now, what you'll find is that the technology will always give you more precision than using the tables. So if you take it out to more decimal places, it'd be actually more accurate than by hand using tables. Okay, let's take a look at the next one. Number 3 here says determine the area under the standard normal curve that lies between 0.31 and 0.84. And I could probably edit, paste, deselect. And this is between 0.31 and 0.84. 0.31 and 0.84. Okay. Now, when you're doing these by hand using tables, when it's the between two values like this, you always take your larger value, put it first, and shade the area to the left, minus your smaller value, and then shade to the left. If you were to graphically look at this and you had this, and if I subtracted off this piece, that would leave you a piece in the middle. Key part is to know is they crisscross. 0.84 is here, 0.84 goes there. 0.31 here, 0.31 goes here. Now this is 0.8, and the hundredths place is 0.04. Okay, so 0.8 right here, and 0.04 would be right here. And we're looking at the intersection of those. And that would tell us 0.7995. Minus, and then we're looking up this one. So we're looking up 0.3 in the hundredths place separate, 0.01. So 0.03 is right here, and 0.01 is right there. So the intersection of those would be this. So 0.6217. And if I subtract those, let's see, 0.7995 minus 0.6217 gives us 0.1778. Okay, so using R, still the same picture, but we're finding this right here. Again, since we're talking about z-scores, technically this would be a z in the middle, but I'm just using x to represent the value we're trying to find. But I mentioned that because if you got a problem asking you to find it and they have z there, they're asking you to find in terms of z-scores, which means mean is 0, standard deviation is 1. Okay, so this tells us that we want to plug it into this formula. So this is A, this is B, and we want to do P norm B, comma, mu, comma, sigma, minus P norm A, comma, mu, comma, sigma. You're going to see a direct comparison to what I'm putting in here to how we did it over here by hand. That's what we did over there, right? We swapped these. Those swapped. So B went first, A went second. Okay, so we're going to have P norm. And just to really demonstrate it, if your mean is truly, and standard normal indicates that, if mean is 0 and your sigma is 1, so mean is 0, standard deviation is 1, then you don't need to put those. So I'm going to put in my, what was B? 0.84 minus P norm, forgive my writing, and A, which is 0.31. Okay. So my eyes get worse. I have a harder time seeing my mouse cursor. I need to take time to actually increase the size of it. Number 3, P norm 0.84 minus P norm 0.31. 0.31, yeah. And if we run that, rounded to 4 decimal places, 0.1778. And you see it matches. Okay. So let's take a look at problem number 4 then. See what's different about that. I'll grab a drink here. Okay, determine the area on the standard normal curve that lies to the left of negative 3.32 or to the right of 0.24. Let me grab those. What was that? What did it just do? I think I chose the wrong one. Not that that matters. And then edit, deselect, choose my paint. Okay. Left of negative 3.32. It's a pretty small z-score. Right at 0.24. So that's what we're trying to find. Now, and this just shows you one example you could have. Pretty much what we looked at before was everything you could have. You know, the area to the left, area to the right, area between two values. You know, there's really no other choice there. Now, if you have this, you can split these up. Because if I take that area there and add it to this area over here, that'd give me the same thing as this right here, assuming I'd drawn everything correctly. Okay. Well, this is good here, because this is based upon the area left, which is what we want. Now, remember I said when it's the area to the right, you always rewrite it as 1 minus, and then you change this to the area to the left. So we leave the first one as is, we rewrite the second one. Now here I'm going to look up negative 3.3, and then my hundredths place separately. So 0.02. Negative 3.3 and 0.02. The intersection of those would be that right there. So I got 0.0005 plus 1 minus, and here I'm looking up 0.2, and I separate the hundredths place, 0.04. So I'm looking at the intersection of 0.2 and 0.04. Which I look at the intersection of that, and that gives me 0.5948. And let's see what that gives us. 1.0005 minus 0.5948, 0.4057. Okay, so using R, if I got the same picture, I don't have a form that gives you this. So you have to split this up. Now, whether you just do it in your head or actually write it out, it's the same principle as what we just did. We got that plus the area to the right. So this one would be x is less than or equal to negative 3.32 plus, and this is x is greater than or equal to 0.24. Let's do this one first. Less than or equal to. That's form 1 here. So what we plug it into is this right here, P norm A mu sigma. So this is P norm A, which is negative 3.32. And we're still talking about our standard normal. So I'll put 0 and 1 there to indicate it, but as we've seen, you don't need to put it. This other one is going to be a different form, but this will still be A. That's my greater than or equal to case. And that says we rewrite as 1 minus P norm A mu sigma. So plus 1 minus P norm A, which is 0.24, mu 0, sigma, which is 1. Does that look familiar? It's got the same setup as there, isn't it? Okay, so get to R. P norm negative 3.3201 plus 1 minus P norm 0.2401. Run that. 0.4056 rounded to four decimal places. Now notice, came up with a different value here, didn't we? Let's make sure I saw it correctly. 0.40561. So it is slightly different. Again, when we're doing technology, we're assuming I plugged all the numbers in correctly. I should check that. We're using technology. Sometimes it's slightly different. The technology is more precise. The by hand is limited to 4 decimal places. So, okay. That was number 4. Let me clear that off. And let's take a look at number 5. Now, by the way, these here will be the same on the problems where you have a mean and standard deviation given. It's exact same setup, but instead of putting 0 and 1 in, you put whatever your mean and your standard deviation is. So I may not show you a lot of examples of that, but keep in mind it's the same. Find a z-score such that the area under the standard normal curve to the left is 0.7. Okay, to the left. Let's try that again. And left is 0.7. So what they're telling you is they're giving you the area of the probability. They're telling us the area left is 0.7. And we're trying to find this value, which they're referring to it as a z-score. The z-score or z value is when you're talking about the standard normal. When your mean is 0 and your standard deviation is 1. Now this is good because our table is based upon the area to the left. Okay, Shift S. The book doesn't really emphasize tables to a whole lot. To find this any other way besides using R, you would have to use calculus, which is beyond this class. Okay, paste, move it down, move it over there, I guess. Edit, deselect, paintbrush. This is going to seem weird and it'll seem kind of imprecise. But we look up the area to the left, so it has to be the area left, in the middle of the table. So you're looking for the value closest to 0.7. Now here's 0.6985, which is 0.0015 off. And here's 0.7019, which is 0.0019 off. The one that's closest is this right here. So then I come over to this side to get first part of my number. And I come straight up to get my second part of my number, my hundreds place. So my answer will be 0.5. That's the first part of my number. And then my hundreds place is 2. So I put a 2 there. Okay, so let's take a look how to do it with R. Same type of setup. We're still trying to find that value right there. And again, I'm not trying to draw this in the correct form. If this is 70%, it definitely wouldn't be this far to the left. But okay, so now if you're finding the probability, you're using P norm. If you're finding the value, if it says anything besides probability, percentage, proportion, or area, or unusual, which this one is saying something different, then you find the value. And you pass in the probability. This is the area to the left. And then you move and then your sigma into Q norm. So for this one, I'm going to put in Q norm. Our area to the left, which is 0.7. Our mean, which is 0. Standard deviation is 1. Again, if it's 0 and 1, you don't have to actually put it. You could do Q norm 0.7 closing parentheses. Q norm 0.701 Run that. And we get 0.52. I think that's all the decimal places we took it to here. Yeah, 0.52. Again, with technology, we can have access to more decimal places, so it's better than doing it by hand. Okay, so let's take a look at the next problem. And number 6. Okay, find a z-score such that area to the right is 0.4. So 40% over here. Because it says the area under the standard normal curve to the right is 0.4. Well, all of this adds up to 100%. So if you got 40% over here, you're going to have 60% over here. Now we're still trying to find this value right here. And we have to look at the area to the left of that. The area to the left of that is 0.60. So, looking in our table, let me take a snapshot of that. And edit, paste, edit, deselect. Oh, no, I got to move it. Let's try it again. There we go. Edit, deselect. There. Okay, so again, this table is based upon the area to the left. That's why we look up 0.6 instead of 0.4. So we're looking for the value in the middle here, closest to 0.60. Now here's a 0.5987, which is 0.0013 off. Here's a 0.6026, but that's 0.0026 off. The value that's closest to 0.6 is right here. So I come over here, that'll give me my first part of my number. Then I come straight up, and give me my second part of my number. So my answer, I'm going to have 0.2, and my hundredths place is 5. Okay, now using R. Again, if we're given the 40% over here, we have to figure this. That's 60%, because the R function Q norm is based upon the area to the left. So we need this value. So I won't flip back there, but it said Q norm, area to the left, which is 0.6, our mean, and then our standard deviation. Okay, so number 6, Q norm, 60%, 0, 1. And you don't need to put zeros there in case you're wondering. You could just put 0.6. And that gives us 0.25 to 2 decimal places, which matches that. Like I said, the book probably doesn't really emphasize the tables at all. It might not even have any in the back. But if you want to get a table and see how to do it by hand, go to Google, type in standard normal distribution table, PDF, and you'll find different ones out there. Make sure it's based upon the area to the left. I tutored a student one semester that was using a book off of the area to the right. And, I never was so confused. But maybe that's because I learned the area to the left. Let's take a look at number 7 here. Okay. And number 7 says, find the z-scores to separate the middle 90% of the distribution from the area and tails of the standard normal distribution. Okay. 90%. So they're telling us the amount in the middle is 90%. Now all of this adds up to 100%. And though I haven't drawn any of them that way, these are symmetric, which means the area over here is the same as the area over here. So if 90% is in the middle, that means we got 10% that we split up in the tails. If you take your 10%, divide by 2, it'll put 5% in each tail. So that'll be 0.05, and that'll be 0.05. Now we got two values we're going to find here. And I'll just label this as Z1 and this as Z2 to indicate they're Z-scores, Z values, but they're different. Now I'm going to look up Z1 first in our table. And this is based upon the area to the left. The area to the left of that is 0.05. So area to the left, abbreviated as ATL, would be 0.05. Okay, so let me bring up that table. Okay, so we're looking for the value in there closest to 0.05. Now I chose this one for a specific reason. Here is 0.0505, which is 0.0005 away. And here is 0.0495, which is 0.0005 away. Both of those are equal distance. So 0.05 actually falls halfway in between there. When it falls exactly in between there, then what you do is you again come over here to get the first part of your number. So Z is equal to negative 1.6. And since it's exactly halfway in between here, you come straight up, assuming I could draw a straight line, to the value that's halfway in between here, which would be 0.045. So we would put in 4.5 here. You don't do that for any other case except for it's exactly in the middle like that. You don't say, well, it's closer to that one, so I go with that one, or I mean, if it's a quarter of the way over, so I kind of do a quarter. No, you don't do that. Just when it's exactly in the middle like that. Okay, now we need this other one. The area to the left, ATL. And we're looking at this one right here. You have to add up all the area to the left. So 0.05 plus 0.90. All the area left will be 0.95. Now that isn't in this particular table. You'll find oftentimes these tables have 2 pages to them. Sometimes they're a little bit strange and they don't. But if you are looking for a table because you like to see it visually like that, look for a table that has both positive and negative z-scores. It's easier to use in my opinion. Okay, this one. And let me paste that in. Edit, deselect, paint. Okay, so we're looking for the value closest to 0.95 in here. And this is very similar to the other one. Oops, forget that. It's this one. This one is 0.0005 away. This is 0.0005. If I said that right, 0.0005 away. So again, it's halfway in between. We come over here to get the first part of our number. That's Z1, I should say. And this is Z2 is 1.6. And then since it's exactly halfway in between these, I come up to here. And since this is exactly in the middle of that, that'd be 0.045. So I put in a 4.5 here. You may be wondering, will it always come out the same like that, except for the sign's different? It will be if we're talking about standard normal distribution. Not any other case, so. Okay, now let's do it via R. You still split your amounts up, put 90% in the middle, and put 5% in tails, just like before. We're still finding Z1 and Z2. We're still looking at the area to the left. That hasn't changed. Because remember, Q norm is based upon the area to the left. So this one will be Q norm. And then I'll put in 0.05, and then 0, and then 1. And this one, the area left is still 0.95, same reasoning as above. And we'll do Q norm 0.95 and then 0 and 1. Okay, so let me come over to R. And Q norm 0.05. And was it 0.95? 0.95. By the way, you'll see that there's a lower tail option. I'm ignoring that because I'm just trying to keep it very simple on how to plug these in. So if you're more of an advanced user, you can go and Google that and read about the lower tail, and it does make it a little bit easier. But again, I'm ignoring that. I find students learn better if you just give them one technique and say this is it. At least until their skills increase. Okay, negative 1.645 if I rounded to 3 decimal places, and then positive 1.645. And that was number 7. Okay, let's clear this off, and then we'll look at number 8. And grab a drink here. Okay, assume that the random variable x is normally distributed with a mean of 30 and standard deviation of 5. Okay, so mu is 30, standard deviation is 5. It says compute the following probabilities. Be sure to draw a normal curve with the area corresponding to probability shaded. Probability x is greater than 33.2. So x is 33.2. Greater than would be shaded this way. Now, if we're doing it by hand, and R is a little bit easier, so I'll eventually here quit showing you how to do it by hand. Back here we had this formula. Z is equal to x minus mu over sigma. This is what allows you to put it into the form of a z value. And if we got that z-score, that z-value, we can use our tables. So if you're trying to use tables, you first have to convert this. So z is equal to x minus mu over sigma. X is 33.2 minus mu, which is 30, over sigma, which is 5. And put it all in at once, you got to put parentheses on top. Order of operations. Divided by 5. Be 0.64. So our picture now becomes I'm not getting ready to be torn apart by wild wolves. That's my dogs. They like to play with each other. And get back down here. Shift S, grab the table. Paste that in to get ready. And edit, deselect. Okay. Now remember, our table is based upon the area to the left. So on this one, remember when it's shaded to the right, we always rewrite it as 1 minus the same z-score, but now shaded to the left. That's how you always do the shaded to the right. Now we're going to look up this number. We'll split apart the hundredths place. So we're going to look at the intersection of 0.6, which is right there, and 0.04, which is right there. And the intersection of those would be 0.7389. So we've got 1 minus 0.7389. And 1 minus 0.7389, 0.2611. Okay, so let's back on up here. We're going to do it via R, which is easier. Mu is equal to 30, sigma is equal to 5. We're trying to find the probability that x is greater than or equal to 33.2. Again, it could be greater than or equal to or greater than. It's still the same principle. Now, this is going to be our A. And what I'm going off of is back to our table. Greater than or equal to right here. A is what follows your greater than or equal to symbol. So we're going to have 1 minus P norm. So this is going to be 1 minus P norm, and then I'm just plugging in those values. A, which is 33.2, comma mu, which is 30, comma sigma, which is 5. In this case, it is important you put those values. You can't leave those last two off. Leave it off, it defaults to the standard normal. What did I just say? 1 minus P norm, 33.2, comma 30, comma 5. And run that. And 4 decimal places, we get 0.2611. And matches that. Again, this does have the, you can specify the tail, which way it's shaded and so forth. But I'm just going strictly with this because it matches the by hand approach. Yeah, let's look at number 9. Okay. Probability x is less than 18. And then mu is still 30. And sigma is still 5. Okay. I could draw the picture if I want, but I know I need to change it to a z-score if I'm doing it by hand. So I can jump directly to that. Z is equal to x minus mu over sigma. So I'm going to have 18 minus 30 over 5. And 18 minus 30 divided by 5, negative 2.4. Keep in mind that's negative 2.40. Okay, so z is equal to negative 2.40, and less than would be shaded to the left. So it looks like this, which is good because the table is based upon the area to the left. And so, grab that. Edit, deselect. Now, the reason why I put the 0 there is you have to keep in mind this is negative 2.4 for the first part of my number, and my hundredths place, since it isn't there, is a 0. So we're looking at the intersection of negative 2.4 and 0.00, which would give us this right here. So 0.0082. would be our answer. Okay, now let's do it again using R. So probability X is less than 18. Mu is 30. Sigma is equal to 5. And you'll start understanding why technology is preferred. Okay. Up here. It's less than or equal to, which is this form. A is what follows your less than or equal to symbol, which I just identified. And then you do P norm, A, mu, sigma. So this one's going to be, or I guess I didn't identify it, but this is A. So I'm going to have P norm, A, which is 18, mu, which is 30, and sigma, which is 5. So P norm 1835. And that gives us 0.0082, rounded to 4 decimal places, which matches that. Okay. That was number 9. So let's take a look at number 10. Probability, and it's 32.7 to 33.6. Now I'm not doing any kind of interpretation here. I'm not even talking what a normal curve is. That's more what the book will describe. I'm just showing you how to use technology to find these. So keep that in mind. If you're sitting there, well, you haven't even explained what a normal distribution is. No, that's not my goal. Okay, so if I was doing it by hand, we have 2 values here. And I'll label this one as like x1 and label this one as x2. So we would need to change both of these to z-scores. So z1 is equal to x1 minus mu over sigma. And this one would be z2 is equal to x2 minus mu over sigma. So we're going to have x1, which is 32.7 minus mu, which is 30, over sigma, which is 5. And this one, x2 is 33.6 minus 30 over sigma, which is 5. So let's see. 32.7 minus 30 divided by 5 gives us 0.54, 0.54. And 33.6 minus mu, which is 30, close parentheses, divided by 5, 0.72. Now our picture, since it's between these 2 values, we're going to have it between 0.54 and 0.72. And these are z values, so they're z values, meaning that my mean has now become transformed into 0, and my standard deviation is 1. Remember this is the crisscross. So I'll draw the picture such that this is over on the left side, 0.72, the area to the left, minus, and then this one is over on the right side, and it's area left. And I think I designed this problem so it could use all the values in this one table right here. Now our first one. We're looking up, we're going to split this up, the 0.7 and then the hundreds place. So we're looking at the 0.7 intersecting the hundreds place of 0.02. And that's going to give us this. So that's 0.7642 minus, and here I'm looking up 0.5 in the hundreds place is 0.04. So I'm looking at the intersection of 0.5 and 0.04. And that's going to give us 0.7054. And 0.7642 minus 0.7054 gives us 0.0588. That was a lot of work. Okay, let's do a VR now. We're going to see how much easier it is. And that was this one. So probability of 32.7. And what's the other one? 33.6. Mean was 30. Standard deviation was 5. Okay, so if I were to draw it, that's 32.7 to 33.6. Shaded in like that. It gives you a visual, but you know it's between two values case then. So if I come back to my table, the between two values is obviously this one here. A is my smaller number, B is my larger number. So this is A, this is B. And it says we're going to plug in this formula. P norm B mu sigma minus P norm A mu sigma. So P norm B, which is 33.6, 35 minus P norm A, which is 32.7, 35. And again, notice much easier, isn't it? Number 10, P norm something, 33.6, 635 minus P norm 32.7, 35. And we get 0.0588 rounded 4 decimal places, which matches that. Okay, so that was number 10. Let's look at number 11. '76th percentile. Edit, deselect. what was this again? 76th percentile. So we're trying to find a value. When they say 76th percentile, they're talking about the area, the percentage, the probability to the left is 0.76. That works out pretty good because that's what our table is based upon. And mean is 30, standard deviation is 5. Okay, well, let's go to our table and get that transferred over. This is a little bit different by hand. Now, we're trying to find this value here. So we're trying to find x. Well, we got a formula. It says z is equal to x minus mu over sigma. And so if we're trying to find x, x is in this formula. And we're given mu and we're given sigma. If we add the z-score, then we could find x. So that's what you're going to do first. Your first step is to look up the area to the left, which is 0.76, into your table. Again, you look for the value closest to it. This is 0.002 off. This is 0.0011 off. So the one closest to 76 is this. So I come over here, that gives me my first part of the number. I come up here, that gives me my second part of my number. So the z, based upon that table, is going to be 0.7, and then my hundredths place is 1. Now that we know mu, sigma, and z, we can plug it into here. So I got 0.71 is equal to x minus 30 over 5. And solve for x. So I multiply both sides by 5. And so far I've been pretty good. I haven't made any mistakes that I've noticed. So watch me screw this up. So that's 5, 3. 5's cancel over here. We got x minus 30. Take negative 30 over and got 30 plus 3.55 equals x, which gives us 33.55. Given that mean and that standard deviation, this would be our 76th percentile. We're going to check with R because I didn't use calculator in that, so I'm not very good at decimals. Okay, so same setup. We're trying to find this. We said the 76th percentile meant this area over here. Mu is still 30. Sigma is equal to 5. And notice I put to find a value, it says include percentile. So many students, when they see the word percentile, think that it's like percentage. So they think it's P norm, and it's not, it's Q norm. Now remember, Q norm is probability is always the area to the left. So for this one, this is perfect because I'm given the area to the left of this. So we're going to do Q norm, the area to the left, which is 0.76, our mean, which is 30, and our standard deviation, which is 5. Okay, so number 11, Q norm 0.76, comma 30, comma 5. And I'll run that. And we get 33.53. 33.55. That's assuming I typed it all in correctly. Looks like I did. You will not always get the exact value unless I really did mess up on my math there. Let me see. 33 or 5 times 0.71. 3.55. The 5s would cancel. Add 30 to that. I shouldn't need to plug that in my calculator. 33.55. Okay, so we do get slightly different. Again, the technology is more accurate. So keep that in mind. Oops, I didn't mean to do that. Or maybe I did. Yeah. Now the last one has many parts to it, and I'm done showing them by hand. I think you get the idea on that. So I'm gonna do the number 12 just on the calculator, just in R programming. I'm so used to teaching with the TA3, TA4, I have to rethink. Okay. Test scores normally distributed. The mean is 65. So mu is 65, and a standard deviation of 5. A. What is the score that separates the top 45% of the class from the rest? Top 45%. That means they're giving us the percent over here. Let me go ahead and write all these other ones down. B. What is the score that separates the bottom 80%? Bottom 80% means the 80% is over here. And what is the score separates the middle? Scores separate the middle 90%. So telling us the amount in the middle is 90%. Okay, so let's go to our table. Let's go to our formula. Remember, if you're finding the value, we're using Q-norm. And Q-norm is first parameter's probability, which is always the area left. Okay, if this is 45%, all this adds up to 100%. This will be 55%. So trying to find this value right here, I'm going to have Q-norm, the area to the left, which is 0.55, comma our mean, which is 65, comma our standard deviation, which is 5. Now on B, we want to find this. And the area to the left of this is 0.80. So I'm going to do Q norm, 0.8, comma our mean, comma our standard deviation. And here we got two values that we're trying to find. So on the first one, we have to know what this is. Now, if we put 90% in the middle, all of it adds up to 100%. Then that means we're going to have 10%. We're going to split it in tails. So I'll put 5% here and 5% here. So this would be Q norm 0.05, and then our mean, which is 65, and then our standard deviation, which is 5. And then this one. This will be Q norm. And this one you have to add up all the area left. So you have to add up both of these. 0.05 plus 0.9 gives us 0.95, comma 65, comma 5. Okay, so this is number 12. And we're going to have Q norm 0.55, comma 65, comma 5. We'll have Q norm 0.8, 65, comma 5. And we'll have two over here, Q norm 0.05, 65, 5, and 95. Q norm 0.95, 65, comma 5. And run those. First value would be 65.63. Next one would be 69.21. Then 56.78 and 73.22. Going from left to right. Now, the book will talk more about what this is used for, but this would help you. Like if I'm trying to find a value that would separate the bottom 90% from the top 10%. You know, example might be if I was doing a warranty and I wanted to pay off on 10% of the claims. This might tell me how long should my warranty be. Instead of a wild guess, you could use this to come up with an actual value. Now, you do have to have past trends in order to do a prediction, but that would be an example of it. Well, that's how to do the random normal distribution in the R programming language.